Hello AFM students, this is Miss Van Vickle, and this is part one of what we did on Monday, March 23rd, during your not spring break week. We began our lesson, our study of trigonometry, by reviewing the trig ratios and finding them in a triangle. And I've drawn one right here. It's the one we used in class. And we're taking a look at this triangle from the viewpoint of theta. This is our angle. And we want to find the sine, cosine, and tangent, along with the reciprocal functions cosecant, secant, and cotangent. So let's take a minute to refresh our memories on what sine is. Sine would be opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So let's find those trig ratios for our angle theta here marked in our triangle. So I'm looking at theta, and this is the opposite side, so it would be opposite over, it looks like I need to find out what the hypotenuse measure is. So I can use my handy dandy Pythagorean theorem that says a squared plus b squared is equal to c squared to find the measure of my hypotenuse. 4 squared plus 3 squared equals c squared, which is 16 plus 9. So c squared is equal to 25, and c would be 5. So my hypotenuse has a length of 5 units. So now I can go ahead and calculate my sine, which is 4 over 5. And my cosine, which is adjacent over hypotenuse, or 3 over 5. My tangent is opposite over adjacent, so that would be 4 over 3. Now, some of you may have heard of cosecant. Cosecant is the reciprocal of sine, so we're simply going to take our sine and we're going to have hypotenuse over opposite, or 5/4. Some of you may or may not have heard of secant. That's what the word looks like spelled out. And secant is defined as the reciprocal of cosine, so it would be hypotenuse over adjacent, or 5 over 3. And cotangent is going to be the reciprocal of our tangent ratio, so it's going to be adjacent over opposite, which is 3 over 4. So these are my 6 trig ratios for my nice little 3, 4, 5 triangle that I have drawn here for angle theta in that triangle. Keep in mind, if I change my angle, if I start looking at this angle, then I've changed all the ratios, because opposite becomes 3 and adjacent becomes 4. And it looks just a little different, doesn't it? So I want to take a moment to observe something that's true about our sine and cosine ratios. Notice that the hypotenuse is in the denominator of both of these ratios. And so by definition, I can never have a sine that's bigger than 1. Because I'm always going to have an opposite side that's smaller than the hypotenuse and an adjacent side that is smaller than the hypotenuse. So if you see somebody say the sine of theta is equal to 2.5, that doesn't work. And that's the end of part 1. Stay tuned for the rest.